Hello children, good morning. Hope you're all doing good. Welcome back to the science class. Hope you all had a good and safe holidays. So in the second term, I'm going to start a new lesson called acoustics. What strikes in your mind when you see these pictures? Yes, every day we used to get up by hearing either by an alarm or by chirping of birds, or sometimes by our mother's call. So I am going to take a lesson called acoustics. What is acoustics? Acoustics is a branch of physics that deals with production, transmission, control, reception and effects of sound. When you think about sound, I'm sure certain questions will strike in your mind. The questions are: how is sound produced? What is sound? How does the sound reach our ears from various sources? Is it a force or energy? Let us answer all these questions in this lesson. So, when you touch a ringing bell or a musical instrument while it is playing music, you can conclude that sound is produced by vibrations. When the vibrating objects produce energy in the form of waves, which is nothing but sound waves. Suppose you and your friend are on the moon, will you able to hear the sound produced by your friend? The answer is no. As moon does not have any air, you will not be able to hear any sound produced by your friend. This concludes that sound need a material medium like water, air, steel, etc. for its propagation. So sound need either a solid medium or a liquid medium or a gaseous medium. So what are sound waves? Sound waves are longitudinal waves which can travel through mediums like solid, liquid and gas. The speed of the sound depends on the properties of the medium. As sound travels through a medium, the particles of the medium vibrate along the direction of the propagation of wave. This displacement involves the longitudinal displacement of the individual molecules from their mean position. This results a series of high and low pressure regions called compression and rarefaction. Compression is a region where the molecules are closer with each other, and rarefaction is a region in which the molecules are slightly farther away from each other. Let us categorize the sound waves based on the frequencies. The first category is audible sound waves. What are audible sound waves? The sound waves with frequency ranging between 20 Hz to 20,000 Hz are audible sound waves, and these waves are generated by vocal cords or by stretched strings, etc. The next category is infrasonic wave. The waves with frequency below than 20 Hz are called infrasonic waves. These waves cannot be heard by human ear. Waves produced during earthquake are example for infrasonic waves. What are ultrasonic waves? Waves with frequency above 20,000 hertz are called ultrasonic waves. Bats, human cannot detect these waves, but certain creatures like mosquitoes, dogs, dolphins can hear these waves. Waves produced by bats are example for ultrasonic waves. Let's differentiate between sound waves and light waves. Sound waves need a material medium for propagation like solid, liquid and gas. But light does not need any material medium for its propagation. Sound can even travel through vacuum. Sound waves are longitudinal waves, but light waves are transfer waves. Sound waves travels at a speed of 350 meter per second in normal temperature. But light waves travel at the speed of 3 into 10 to the power 8 meter per second in vacuum or in air. When we talk about velocity which is associated with any wave, there are two velocities, namely particle velocity and wave velocity. What is particle velocity? The velocity with which the particles of the medium vibrate in order to transfer the energy in the form of waves is called particle velocity. If you see this picture, when the drum skin begins to vibrate, the vibration passes to the air particles which is next to the drum skin and forms a compression over there. Then the vibration moves to the next particles and so on. So there will be a formation of compression and rarefaction. So what is wave velocity? The velocity with which wave travels through the medium is called wave velocity, or we can say the distance travelled by a sound wave in unit time is called the velocity of a sound wave. Let's take the distance travelled by one wave is called wavelength, which is lambda, and time taken for its propagation is one time period which is t. Then the velocity of sound is lambda by t. So velocity of sound is lambda by t. Therefore, velocity can be defined as distance travelled per second by a sound wave. So let the frequency n is equal to 1 by t. Substitute this in the velocity. So t and t gets cancelled. The remaining will be velocity is equal to n lambda. Velocity of sound wave is maximum in solid and least in gas, moderate in liquids. This is due to elastic property of the medium. Let's see what are the factors that affects velocity of sound. The first factor is density. See, in solid, the density, the velocity decreases with increase in density, but in gases it is different. If you see, the speed of the sound is inversely proportional to the square root of the density of the gas. So as the density of the gas increases, the speed of the sound decreases. The next factor is temperature. The speed of the sound in gas increases with increase in temperature. So temperature is directly proportional to the speed of the sound wave. Okay, if the temperature increases, then the speed of the sound wave also increases. The next factor is humidity. Humidity is also directly proportional. If humidity increases, then the velocity of sound also increases. So these are the three factors that affects velocity of sound. Okay, this table shows the speed of sound in different media. It also reveals that the speed of sound is maximum in the solids and least in the gases. What is reflection of sound? See, when sound waves comes from one medium and strikes the surface of the other medium, then it bounces back to the first medium, in the same medium, then it is called reflection of sound. When sound waves strikes the surface and bounce back to the same medium, it is called reflection of sound. Like a light, the bouncing back of light is called reflection. Same way, if a sound wave bounced back, it is reflection of sound. What do you remember by seeing this picture? Do you remember laws of reflection? Yes. See, this is the source of sound from which a sound wave propagates, and it strikes a surface, and at the point of incidence it just reflected. Okay, the wave that comes from the source and strikes a surface is called incident sound wave, and the point at which the incident sound wave strikes the surface is called point of surface. Then at the point of surface, the incident wave just reflected back. This is called reflected sound wave. And an imaginary line that drawn perpendicularly at the point of incidence is called normal. So what is the first law? So the first law is the incident sound wave and the reflected sound wave and the normal all lie in the same plane. This is the first law. Do you remember the second law? Yes, the second law is angle of incidence is always equal to angle of reflection. What is angle of incidence? The angle formed between the incident sound wave and normal is called angle of incidence. What is angle of reflection? The angle formed between the normal and the reflected sound wave is called angle of reflection, which is R. So the second law is angle of incidence I is always equal to angle of reflection R. This is the second law.
That's all about today's class, children. Please go to page numbers 59 to 62 in Unit 5. I will meet you in the next class. Till then, bye bye. Thank you.